Hello all. So in this presentation, I'll be talking about model compression for NLP, and the aim of this presentation is to introduce you and motivate towards this particular problem of model compression. So with the rise of deep neural networks, what has been happening is with time, the number of parameters and the depth of the neural networks have been increasing. And there have been theoretical evidences and experimental evidences to support the fact that with increase in parameters and depth, what happens is the expressivity of these networks increase and they allow you to get higher accuracy for a particular task. But this higher accuracy comes at a cost. The cost is that it increases the processing time and it also increases the memory required to actually deploy this model in an online fashion. So the idea is to reduce the number of parameters required in those neural networks and retain the accuracy or retain the knowledge learned by these particular neural networks. And hence you want to learn efficient neural networks so that you can deploy it in a faster manner, in an online manner. So model compression techniques can be categorized into four major sects. The first one is parameter pruning and sharing. What happens over here is you identify redundant parameters in the neural network and then delete them or prune them out. The second method is low rank factorization, where you use matrix decomposition techniques to reduce the rank of the parameter matrix and identify which are the informative parameters. So the first two are pretty much similar. The third technique is quite specific to convolution neural networks, since most of the literature comes from the computer vision research, and the idea is to build compact convolutional filters, and these are specific to CNNs. And the fourth approach is knowledge distillation, which I'll be talking in detail towards the end of my presentation. So parameter pruning and sharing is one of the oldest methods of model compression and pruning, and it was developed in 1990 by Jan LeCun, much ahead of its time, where this problem didn't even exist. Perhaps the neural networks were barely working during that time. What the approach was that you identify or create an objective function to characterize the importance of the parameters. What do I mean is that you want to know that how important is this particular parameter to my objective function. In other words, how important is this particular parameter for my accuracy or for my regression task, or etc., etc. And delete those parameters which are not important. And this was done using second derivative analysis of these parameters with respect to the loss term and some other approximation. So as I said, a lot of work on model compression for computer vision problems have been done, but obviously there are other interesting problems like natural language processing, text processing, into which these problems didn't even arise until now and have not been applied to. So channel pruning has been successful for convolution neural networks, and convolutional neural networks, as you would have known, are mostly for computer vision. But these are some of the state-of-the-art techniques, and these are specific to those convolution neural networks, and they work better than most of the techniques. So what perhaps might be interesting if we can come up with some similar techniques for NLP models, where now there is a recent trend which is coming up, which I'll be talking about. So until now, what happened in NLP was the models were not as much complex for most of the tasks. But now there is a drive that people want to come up with huge models, which are one-for-all models, where this model captures the representations of text. And these representations can be useful for any task, be it text classification, be it language modeling or translation, etc., etc. And you want to use this whole model and just fine-tune it for a downstream task and then use these models. But these models are like 100x huge than what you used to do previously, where you have smaller models. So now this particular problem of model compression becomes quite relevant for natural language processing. But since this development of coming out with those huge pre-trained models for NLP is quite recent, as recent as towards the end of 2018 or mid-2018, model compression has not been looked into towards this particular task, and it would be a good future work if you can come up with it. What has been done for model compression is purely knowledge distillation. What happens over here is it's like a student-teacher system, where there is a teacher which you can imagine as the large model that you want to that you want to extract the representations from and compress. And this teacher would allow a smaller model, the student, to learn the representations from. Because as I said earlier, these larger models have higher expressivity and can learn more things than the student models. And what you can do is create an objective function, and this objective function is helping this particular student network to capture all the representations learned by the teacher network along with the classification objective that you have. So this is what has been done till now and for model compression and NLP, but none of the methods of pruning and sharing have been explored towards in greater detail, and this can be a good future work, or even coming up with wait, how many of you are familiar with attention or transformers? Great. So Pascal, Prof. Pascal would be talking about attention mechanisms in a few lectures, and you'll get to know about transformers and all those things. And then all those things would get pretty clear, because these models that I'm talking about, these huge models, are basically transformers at the core, repeatedly applied. And so yeah, that's the presentation. Thanks.